Welcome to Space Startup News live stream. If you're new, I do this every week at the same time over the weekend, Saturday or Sunday, depending where you're watching from. And I go over the videos I've done this week, just basically recap them and show the images and so on. And then I bring up the comments people have left about the videos and bring up any chat messages. So we have Christian in the house. 4 p.m. is here. Thank you for joining. And okay, and Christine is saying 10 minutes early. Thank you for that. So let's before I start, I do have an X account now. It's at Space Startups Hub. Space Startup News is too long. It's more than 15 characters. And it's taken anyway. So at Space Startup Hub, I'll probably put it in the video description so you can, if you have an X account, I'll be on there as well. So let's get into, and also you can ask any question on here. I said I'm talking about those 2 videos I've done this week, but feel free to ask any question at all. It's good. So let's start with Space Quarters, which is a new company that's just come out of stealth. They've got $5 million in seed funding, and they're working on assembling large orbital structures in space. So they have a website, and these images are from their website. Other than that, the website, there's basically some news articles on their $5 million funding, and that's about it. But we do have a photo of the team. They're based in Japan, pretty a young group of guys, and they're working on building large structures in space. And the problem at the moment is, and I put this in the video, here's the old paradigm and the new paradigm. The old way, the current way of doing things is you build everything on Earth, prefabricate it here on Earth, and then you just transport it into space and then dock the different modules together. That's how you build things. That's how you build the International Space Station. That's how all the commercial space stations, future ones, will be constructed. Prefabricated on Earth and then transported to space. The new paradigm is transport construction materials to space and then assemble everything in space. And if you do it that way, you just flat pack tiles into the payload fairing, transport them into space, and then weld them all together, and you can make very large structures. Really, you're not limited in the size of structures you can make using this approach. And here's the one of the articles. There's a few of them, basically explaining that they got $5 million in a seed round for advanced robotic space construction. And this is how I heard about them, just through a news article, and then I found them on the website. And so the system is called DAC, Space Construction Robotic System, or Robot System, and it's for the innovative in-space construction welding robot system of space quarters. So before we get into the actual system, let's first look at the advantages of using electron beam welding. So there's various different kinds of welding you can use. You can use arc welding, you can use laser welding, but space quarters and their main competitor, which is Think Orbital, are both selected electron beam welding. And there's a couple of reasons why they've done that. First of all, deep, clean and strong welds, which is very important in space. You've got a pressurized area, you've got the vacuum of space, so you're going to need strong welds to keep everything in one piece. Then you've got orbital impactors traveling several kilometers per second, so you have to be able to withstand being hit by space debris. And another advantage is near perfect vacuum in low Earth orbit, which is needed for electron beam welding. On Earth, that would be a problem, creating a vacuum. In space, you have it already, so it's perfect for electron beam welding. And it also works with all the aerospace materials, titanium, aluminium, stainless steel, all the kinds of things rockets are made of and space stations are made of. It works fine with those, which is great. And another thing that's worth mentioning, that some of the comments mentioned I didn't really didn't talk about in the video, is that if you collect all the orbital debris, you could then reforge that into these kind of metal, titanium, aluminium, stainless steel, and use that for your construction material. In other words, rather than shipping it from Earth, if you scavenge and all the scrap metal in space, you could use that for your construction material, which I didn't mention in the video, but it's a good point. And yeah, and the other thing is it uses less energy than competing systems like arc or laser welding, which is important in space. So let's look at the welding robot. So this is a pair of robots that travel along the joints of the panels, welding and inspecting the welds. So there's two of them here. This is from the website. So this is the welding robot. And as you can see, it's going across the seams and welding them. And there's also an inspection robot as well. So like it inspects the welds to make sure that they're done properly. And then you have the assembly robot. That's multiple robots work together to carry and assemble the panels. So obviously the panels have to be put in the right place first before you can do the welding. So you have multiple robots that can make sure the tiles are correctly placed. And once they're correctly placed, then they can be welded together. And so the ecosystem, there's a number of companies working on this area, which I call ISAM, in space assembly and manufacturing. There's one direct competitor, which is Think Orbital, who have exactly the same plan. That is, they're going to ship construction tiles into space. They're going to use electron beam welding to build large structures. In the case of Think Orbital, they tend to be spherical structures, like golf balls or soccer balls. But I think the maximum diameter, I think, is 20 meters, which means an internal volume of something like 4,000 cubic meters, which is 4 times the internal volume of the International Space Station with just one sphere, one cube. So anyway, it's that's a direct competitor to Think Orbital. And then you have some other companies that are working in space, but could be partners. Gitai, working in space and on the moon. They have dual arms that can articulate, so they can hold things, move things around. So potentially they could compete, but they could also partner. Icarus Robotics, that's another new company that's just come out of stealth, and that's more about logistics on the International Space Station, basically packing and unpacking cargo from these cargo vehicles. And apparently that's what astronauts spend 80% of the time doing. It's just packing and unpacking cargo. So the idea is that you'd have robots that could do that, and maybe they could help with logistics for space quarters. And Christian is saying, I see a ton of documentary movie programs about ISS, and the whole station is working, moving, so welding is not the best. Rivets would work out better, or live bolts. Yeah. So we're moving into the area of commercial space stations. So perhaps we'll see more experimentation about what a space station can do and the different components and how it's constructed. I mean, I think because ISS was so expensive, $100 billion, like no one's really done anything else. But now we'll have commercial stations starting from next year. We'll have a lot more experimentation. And Rendezvous Robotics, which is self-assembled tiles using permanent magnets. So that's a completely different and more exotic way of building things in space. But it's already been tested on the ISS, and there's another test in 2026. So who knows? So it's all very exciting anyway. So okay, let's go on to the comments, see what people are saying about this. So we have Micon7629 saying, in vacuum, clean metal powders automatically bond at atomic level and cold weld. A 3D printer with metal powders contained in pressurized containers until deposition could be used to print a spacecraft. Okay, interesting. I didn't know that. And Marty the Martian is saying, 247, I would change transport construction materials to space and make it harvest materials in space in the form of near-Earth asteroids as a source of metals. Yeah, I didn't really bring up this point in the video, but there's a few comments saying there's metals in space already. Why transport them from Earth just get all the defunct satellites and scrap metal that's just floating around, which is a hazard, and just reforge that with a space foundry, and then you got brand new sheet metal. And I've covered companies like Cislunar Industries that are working on metal foundries in space. So that seems to be like you clean up near Earth orbit, and you get brand new metal that you'll have to transport from Earth. So, and Michael Millian is saying, if Starship used an aluminium fuel tank with a much smaller second boost stage, which pushes it into an orbit and returns to Earth, then we could have a lot of fuel in orbit and a lot of raw materials to build large structures in space. Yeah, that's kind of a similar point. Once Starship is in orbit, couldn't you just use that as metal? I guess. I mean, if you pay for Starship and you pay for an expendable version of Starship, you could just then scavenge the metal. So I did check what Starship is made of, and of course it is mostly stainless steel, but there are a few components of aluminium apparently on the avionics mount, and I think some of the batteries probably used copper and so on, and the grid fins use titanium. So it's not just stainless steel, but the vast majority is stainless steel, which you could melt down in a foundry and use for other things. You'd have to pay for an expendable version of Starship, though. And we have another comment here saying, from Mika, yeah, I'm not going to even try and pronounce that. Next up, obtain, manufacture construction materials in space instead of pulling out of gravity well. Yeah, which is the same point again. That yeah, there's metals in space. There's metals in space already, so just scavenge those. One fly in the ointment is you need permission. Even for dead satellites, you need to get permission to use them. And Christine is saying 4G takes a lot of power. It cannot be run on solar panels. So yeah, that's another issue. But let's move on to the second story I have, which is, strangely enough, highly related to what I was talking about, and that's orbital debris. Startups working to clean up space. This is a big issue, and unfortunately, it's getting worse, not better, and it's getting worse quite quickly. So we have this graph from, I think this is from, yeah, it's from ESA, European Space Agency. And you can see the number of collisions predicted. This is in 2005, based on the amount of space debris, something like 100 and odd. And then 2014, when they did the calculation again, 250 collisions detected. This is a long way off. But you can see it's ramping up over time. Now 2023, even near term, the number of collisions detected or predicted is just increasing. And yeah, this is something that has to be dealt with. We can't keep ignoring this problem, otherwise there's going to be collisions. Unfortunately, this is transparent, so unfortunately the text is not very clear. But basically, you can see that there's been what's it saying? There's been collisions, there's been fragments. This is resulting fragments from events. So some of these collisions have been deliberate. Anti-satellite tests, this big area here is an anti-satellite test, and a lot of it is just propulsion and accidental fragments and so on. But it's a big issue, and we need to deal with it. So since the 1st of January 2024, so that's less than 2 years from now, there's been 26 rocket bodies abandoned in orbit, and they will stay in orbit for more than 25 years. That's basically they're in a high altitude, 800,000 kilometers, and at that altitude, they don't experience a lot of atmospheric drag. So they basically stay in orbit for a long time. So Western countries have now decided that all the launchers need to deorbit their upper stages satellites. They have to deorbit within 25 years. So basically, that limits the altitude, and they will naturally get dragged into the atmosphere over time. But China is responsible for launching 21 of 26 hazardous objects since 2024. So that's the vast majority, and unfortunately, that's continuing to today. They're continuing to launch using rockets that can't deorbit the upper stage, and they just stay around. And the problem is the number of mega constellations that are basically being launched and deployed at the moment. You've got Starlink and Starshield, which is not a problem because they deorbit their second stage, SpaceX. You've got OneWeb from UK, France. That's mostly deployed at the moment. 648 already in orbit. You've got the Project Kuiper, 155 deployed, another 3,000 to go. But again, it's a Western launch company, so everything gets deorbited. You've got Iris too. Nothing's launched yet, but there's going to be 290 of those. This is from the EU. And this is where you've got the big problems. You've got two Chinese mega constellations, Guowang from China Satnet. There's only 10 launched, but it's going to be 12,900. And then you got Shanghai Spacecom and Xinfan are 1,000 sales, 648 launched, but eventually it's going to be 14,000. So that's a massive number. Between those two Chinese mega constellations, you've got 25,000 satellites launched on rockets that leave the upper stage in space for a long time. So that's a problem. And Christine is saying maybe China will recycle it or reuse. Maybe it is not all trash. Well, hopefully, I believe the IAC 2025 in Sydney, the Chinese space top guy for Chinese Space Agency said they're looking into being able to deorbit satellites, but the problem is the speed that they're launching them is making the situation worse, not better. Here's a list. You can't see it very well, but it's in the video, and it's linked in the video description. You can see all 50 of the most hazardous, most dangerous upper stages. It's mostly Russian upper stages from the last century. I think something like 3/4 are old Russian SL-16 and SL-8 upper stages, but more recently it's been the Chinese. And actually in second place you have an ESA, NVSat. That's actually ESA upper stage, or actually satellite, but it's 8 tons, and there's already been a lot of conjunctions, over 200 conjunctions or near misses. So that needs to come down pretty quickly. There is a Japanese H2 upper stage, and Japan is working on a mission with Astroscale to rendezvous with it, dock with it, and deorbit it. So the Japanese H2 should be removed in the next couple of years because there's a couple of missions. Astroscale is working with the UK Space Agency to deorbit 2 UK satellites, quite small satellites, I believe. But so that's the first UK mission, and ClearSpace is got a contract with the European Space Agency to deorbit Proba 1, which is a European satellite. So the West is kind of working on the problem. Japan, Europe, and the UK, and also NASA is paying Starfish Space, a US space startup, and potentially 2 US satellites will also be docked with and deorbited at some point. And Christian saying, how dangerous would be to recapture those objects and scrap them in space? We could reuse the materials. So the technology to rendezvous, to maneuver around, to dock is being worked on and will be tested in the next couple of years. In terms of metal foundry, Cislunar Industries is working on a space foundry. It's not deployed yet. I don't know how close to deployment it is. There's probably going to be some tech demos first, I believe. So that's probably 3 to 5 years away, maybe. But once you have the metal foundry, and once you have the technology to capture satellites, potentially then you just have to move it to the space foundry to reforge. So yeah, maybe 3 to 5 years, something like that. So that is all the graphics. So if we look at what people are saying about orbital debris, we have astrophysicists saying deorbiting is hazardous to the environment, to high altitude aircraft, and wasteful of refined metals that are on orbit that should be recycled on orbit for use in an orbit construction. And we have Ian Patrick Reed saying, and you can get the best kind of bonus with the materials. They're already in space. You don't have to pay to get it off the ground. Instant return on investment. And we have Treasure Hunter 3744 saying, it can even be turned into metallic fuel in a version of an ion drive. You can't build, you can burn. Either way, it's dealt with. All good comments, and something I didn't bring up in the video, but yeah, you can just you can basically reforge the spent upper stages into sheet metal or whatever else you need, propellant pipes, which can be used in ion drives. I should probably do a video on that, and the whole ecosystem. That is, collect dead satellites, send them to a metal forge, produce propellant pipes, which can then be used by some space startups. I know of at least 2 companies that have metal propellant drives. One is MagDrive from the UK, and the other, I think, is Newman Drive from Australia. So 2 of them are working on propelling spacecraft using just metal rods. And Newman Drive is working with Cislunar Industries, which is producing the metal foundry. So they will be able to produce exactly the kind of propellant pipe that Newman Drive needs, which is brilliant news. And Christine is saying, you need a 6-ton or 8-ton or some 22-ton Russian old stuff. There's a lot of material already delivered in space at huge cost. Just speed it out and let it burn on the way down. It's pure waste. Of course, you also need permission from the company and the country to use their defunct satellites, because it's still property that's owned. But yeah, obviously it makes a lot of sense to do that. And that's what some of the comments are saying. And Wingsley is saying, it seems the space debris dilemma is the result of a lack of international agreement, framework, and responsibility. No surprise that China and Russia could be the biggest source of the problem, as each are clearly rogue states who seem to be making a point of not caring. As long as rogue states launch articles into space with no responsibility, the problem will escalate. Well, I'm not sure everyone will agree with that point, but yeah, without international agreement, and nothing's going to happen. And I don't really believe anything's going to happen anytime soon. I don't think China is going to stop using the rockets that leave the upper stage. First of all, because you know, those are the rockets they have, so they're going to keep using them. And there is a profit motive. Deorbiting takes more fuel, which reduces your payload, which reduces your profit. So unless companies are forced to do that, I don't see why they would. Why would they choose to make less money? So there's a big problem. I don't see any fix on the horizon. I really don't, because the Western countries are removing the Western satellites. But the problem is getting worse, particularly by China, which I don't see anything on the horizon to fix that. And we have Torben Star 42 saying, wet workshops like NanoRacks Outpost are interesting approaches, repurposing upper stages into space stations or robotic workstations. Further scavenging for other useful hardware could be interesting to follow up. It is very interesting, and thanks for that idea. I should probably do a video on NanoRacks Outpost. I did hear about it, but I forgot about it. But this idea of wet workshops, which goes back to Von Braun, I think he mentioned it for the Apollo stuff, is Saturn V, is that the fuel tanks can have decks in them. You have the drainage holes so the fuel can go through the decks, but basically you have decks. So if you land something on the moon like a starship, the fuel tanks, once they're drained of fuel, you can live on them. They have the decking already, and yeah, so you get double the amount of internal volume for living quarters. So it's a very old idea, wet workshop, but it's a fantastic idea. And I think NanoRacks was working on something like that, refurbishing an old fuel tank. So yeah, maybe I should do a video on that. I'll look into it. But yeah, that's a great comment. And Marty the Martian is saying, time to change focus from debris removal to debris harvesting. Metal mass is needed up there, so we should use what is already up there, which is, so Marty's just echoing the points made by a lot of other commenters, and it's a great point. Yeah, why don't we just use all that metal up there and just reforge it into useful things? And there was a company, I think it's called Orbital Recycling, that had a slight spin on that take, and that is they capture all the satellites, but instead of forging them into metal in low Earth orbit, they send them towards the moon and crash them into the moon, and then you could have robots like Gitai robots that will scrap them, scavenge the metal, and send it to a lunar metal foundry, and then you can forge metal sheets and so on and build metal structures on the moon. So that's kind of interesting. Well, that's a different spin. And there's a company called Orbital Recycling, I believe. So maybe I'll do a video on that as well. So that is everything I wanted to talk about this week. Yeah, so like and subscribe if you like these videos and live streams. And yeah, I do this live stream every week at the same time at the weekend. So please join if you can, or you can watch it later, whatever. And yeah, so see you next week then. Bye.